icon. Okay. So here's what we got. We want to factor. Again, we started using that word yesterday. Okay. We want to factor by finding the greatest common factor, or the biggest piece. And then just to revisit something, okay, a term in the first question, you have what are called terms. There are two of them. Okay. This will be term 1 and term 2. A term is made up of two things. Okay, one, a term can have a number. Okay. And the second thing it can have is a variable, like such x, right? Okay, so when we're finding the greatest common factor, we're trying to find the thing that goes into both terms, or the biggest thing that goes into both terms, okay? That being, it's going to have two pieces, okay, if it's allowed to. The greatest common factor is going to have a number piece and then also a variable. And sometimes what we might see over the course of this lesson is we might even have two variables mixed in there, x and y, right? This is still one term. It just has three things in it. It has a number, an x, and a y. They're all three separate things. Okay, and we're just going to look at what's common, like how many 3's or how many x's, how many y's can I take out of all of them. Okay, that's all we're doing. Is finding the biggest thing that we can take out of all three terms in this question. Okay, so let's go up to the top. That one's a little bit harder. I'm going to build you towards that. Okay, this is just, we're revisiting some stuff from yesterday. Okay, so I always like looking at the question and trying to figure out off the side what my greatest common factor could be. Okay, so I say, okay, I'm looking at this and I'm looking at this. I only see one x here. I don't see an x here, right? So that means I don't have to worry about the variable for this part, or for this question, okay, because there isn't a variable on the second one. So that just means your greatest common factor over here is just going to have a number. Well, what number is it? The number is, but it comes from, anyway, looking at the two terms and figuring out what could I divide both of them by. Okay, well, it looks like both of those are divisible by 2, right? And remember, 2 would be the biggest thing that you could divide both of them by. So the greatest common factor for this question is 2. And then the next step is to, as soon as you identify this, you're writing the greatest common factor out front. Then you open up some brackets and you're going to tell me what's left on the inside of the brackets after you remove this greatest common factor. Well, it looks like 2 can be pulled out of 2x, and so we just get an x left, and then plus 2. Okay? Now, the reason why I know that I'm correct here in this particular question is, if you guys remember doing this from before the break, this is like kind of your check, right? We're like, are we right or wrong? Well, we check to see if we're right or wrong by doing this. This is what we call expansion, right? Or that table from yesterday, where we write the length and width and we multiply the length and width together, right? 2 times x is going to be 2x. That's the first arch, right? The second arch is going to be 2 times 2 plus 4. This matches our original question. So then we know we're right. Okay? So let's go down. We'll look at these two here. Okay, I'm looking again. I have 2 terms this time. Okay, your question is, let's identify the GCF, or greatest common factor. Well, what can I divide both of these by? And remember, it has to go in evenly, okay? It doesn't look like this time I can divide by 3, right? Because 3 doesn't go into, or you can't get a nice even number here, right? So that doesn't work for this one. So there's not going to be a number in my greatest common factor, but there is something else in there that I could factor out. It looks like both of them have an x. So I could divide them both by x. Right? So my greatest common factor is just an x. Now you tell me what's left after you remove that x. Well, you got to write it out front if you're going to remove it. Then you're going to say, okay, well, one of these x's cancels with one of those, and you're left with 3x. And then one of these, this x cancels with this one, plus 2. That's you done. You could confirm that you were right by multiplying it back in if you'd like. That tells you, okay, well, we get 3x squared plus 2x, and you're good. Matches again. Okay? This is your check. Okay, let's do one more up top here. We'll do some harder ones down at the bottom. Okay, I always again start with the GCF. Let's try and figure out what it is. It looks like in this question, I'm going to deal with the numbers first. I'm going to see if there's a number that I could divide both of those by. It looks like I can divide both of them by 5. Alright, so that takes care of the number portion. Okay, it looks like my greatest common factor is going to have a 5 in there. Okay, that's okay, buddy. We're just kind of getting started anyway, okay? Then you turn your attention to the fact that terms also have variables. It doesn't matter what the variable is. It could be a y, it could be an x, right? You're going to look at that and say, okay, is there a y in both of them? At least one. You're going to say, yeah, oh yeah, there is, right? So then I can go, okay, we'll divide both of them by y. So your greatest common factor is 5y, because it's the thing that goes into both of them. Well, if you're going to go rewrite this now, you're going to say, okay, well, I'm going to write my greatest common factor out front, 5y, and then you're going to tell me what's left on the inside after you remove it. What's left? Well, 5y squared divided by 5y. The 5 cancels with the 5. 1y cancels with one of the y's in the top, or the numerator. Right? So I'm just left with a y from the first piece. And then you look again, you go, okay, well, 5, or 10 divided by 5 is going to be 2. Right? 10 divided by 5. But then the y in the bottom cancels with the y in the top. So you're just left with y plus 2. Okay, it's at this point that I know you can check whether or not you're right or wrong by checking with expansion. Okay, or from yesterday, if you'd like, we could do the table method too. Fill in the table. Y times 5y is going to be 5y squared. 2 times 5y is 10y. That looks like our original question. I know you can't really see it now because of scratched over stuff, but that's our original question. 5y squared plus 10y. Then we know we're right. This is our answer to this question for factoring. Okay. That's our answer. All right, does anybody have any questions? Okay, this is just a bunch of the same thing, but today I'm hoping like I'll do a whole bunch of these so you guys have seen, I don't know, by the time we get to the bottom here, 10 questions, you can go do the homework questions without any problems, okay? Or at least have a bunch of questions in a video that you can watch how to do, okay? So as I was saying before, like what I like to do is just every time I see a question like this, factor, I look to see if there is something across all 3 or 2 or 4 or 5, however many terms there are, that I can pull out to make it easier, right? That's the whole idea here. Factoring makes things look easier, right? I'll write that here. It's kind of a rule. Not a rule, it's just what's going on. It's not really a rule. It at the very least makes things look a little bit like nicer to look at. Okay. So if I look at A here, we're going to first try to identify what the greatest common factor is. You're going to look at 2 of these. Okay, you're like, oh, what can I divide both of them by is your question. That's what I suppose another point is, what can I divide all the terms by? Evenly, okay? And the biggest. So it looks like in this first question, if I were to look and try and divide both of these by something, it looks like I could divide them both by 3. 3 is the biggest thing I could divide them by, evenly. Right? So you're like, okay, well, my greatest common factor in this question is 3. And then to actually factor it, you're going to remove it, right? Because if you divide by 3, you must also multiply by 3, right? And what I'm doing here is like, I'm trying to do this in 3, 4, 5 different ways, okay? Maybe not that many, but we saw some of this yesterday too, right? Where if I decide to divide by 3, then you better multiply by 3 as well. Because if you don't, then you've changed the question and we're not allowed to do that. Okay, once you have it in this stage, like right here, now you can just do the math that's on the inside of these brackets, right? 3 divided by 3 is going to be 1, right? And so you're going to rewrite this whole thing as 3 with the 3 out front. 3 divided by 3 is 1x. 6 divided by 3 is 2. And you're done. This is what we call factoring or finding the greatest common factor. Okay? So again, let's try B now. I just like doing this. I don't know, this is just kind of the process that I like to follow, okay? You're asking yourself this question all the time. Every time you try and do one of these questions, or when it says find the greatest common factor anyway, you're trying to say, what can I divide all the terms by? Or what's the biggest thing I can divide all the terms by, I suppose is what it should say. That's what's going on in your head. So you're like, okay, you draw your division statements and you're like, okay, deal with the numbers first, right? Remember, terms have 2 pieces. They have numbers and they have variables, okay? And you're trying to figure out one piece at a time. So let's deal with the numbers. What's the biggest number that I could divide all 3 of those by? It looks like it's 2, right? I can divide all of them by 2. And then therefore you start building your greatest common factor. Well, it looks like my greatest common factor is going to have 2 in it, at least. And then you go back and you're like, okay, let's try and deal with the variable. Well, some of you might be prone or like tempted to do this. Oh, well, just divide them all by x. The problem with that is only the first 2 have x's in them. The last one does not. And remember, it's what can I divide all the terms by? Okay, so that one doesn't work. You can't include the variable on this one because you can't divide them all by x because there's no x on the end, right? So that makes your life a little bit easier from the standpoint that your greatest common factor is a little bit easier. It's just 2, right? And so when you go to rewrite this, if you're going to divide everything by 2, then you got to write the 2 out front. And you're going to go, okay, well, 2x squared plus 4x plus 6 divide by 2, divide by 2, divide by 2. You've now taken care of the fact that you're multiplying and dividing, so nothing's changed, right? And you say, okay, well, what's 2 divided by 2? 4 divided by 2, 6 divided by 2. And you write what the answers are for each one individually. X squared plus 2x plus 3. Okay, we're going to see why we do this later today. But we saw yesterday a little bit what we could do with that. We're going to do a little bit more work with that after at 1 o'clock today, okay? Okay, let's jump down to the next one. Same thing. Try and figure out what my GCF is. GCF is find out what you can divide all of them by. Okay? So let's look at these. Divide, divide, divide. Let's deal with the number first. All the numbers are what we call coefficients. I suppose we need to call them that too. Coefficients. Coefficients are the numbers out front. Okay. So it looks like all 3 of those numbers or coefficients are divisible by 5. All right, well that takes care of the number. So we're starting to build our greatest common factor. It also looks like, now that I've changed my attention, I'm looking at the variable now. Well, it looks like all 3 of these terms, 1, 2, 3, have an x in them. At least one. At least one. There's 3 there, there's 2 there, and there's 1 here. All right, well, it looks like I can divide all of them by, oops, I didn't finish writing these. It looks like I can divide all of these by an x as well. Okay, so you've built your greatest common factor over here on the side. That's the thing that goes out front. So we get 5x. You tell me what's left after you do the math in each term. Okay, so for instance, 5 divided by 5, here I'll use a highlighter. 5 divided by 5 is going to be 1. And then you look at, okay, well, I have an x here. One of these, this x can cancel with one of these up here, and you're left with a 2 instead of a 3. So you're left with an x squared. Okay, that takes care of that term or that piece. Go to the next one. Remember, you have 3 pieces here. Go to the next one. 25 divided by 5, that's the number, is going to be positive 5. Then look at the x's, or the variable. How do I deal with those? One x in the bottom cancels with one of the x's in the top, and we're left with a 1. So we get 5x. Okay, that takes care of term 2. You go to the next one. 10 divided by 5 is positive 2. And this x cancels with this one. And you're done. Does anybody have any questions? Okay, all I'm going to do is make these progressively, not even harder, there's just more stuff in them. That's all. Okay? We only got 3 left. I don't think they're going to get much harder than this, these last 3. Okay, so if you're okay up to this point, you're laughing. Okay, because I'm just going to take that knowledge and just apply it to these next three questions. Okay. So again, I just try and find what my GCF is, or I try and build it. I build it by looking at all three terms individually. I start with the number. What can I divide all three of these by? This one's a little trickier because it's kind of out of order this time. In terms of the numbers, there's just the numbers or coefficients are all over the place. It looks like I can't divide anything. You're just checking to see, okay, I can't divide them all by 6 because 4 divided by 6 is not an even number. So that one doesn't work. You gotta ask yourself, okay, well, what about if I divide them all by 4? Well, 4 doesn't go into 18, and it doesn't go into 6. So that one doesn't work either. Let's go to the next one. Next one down. What about 2? All right, 2 works. I can divide all of those by 2. Okay. So we've built the coefficient piece, or the number piece of our greatest common factor. Okay. Let's look at the variable piece now. It's an x. Let's just see what we can divide them all by. Well, it looks like you can't take 4 x's because this one doesn't have 4 and this one doesn't, but this one has 1. They all have at least 1 x, right? So you can divide them all by at least 1 x. Okay. After you do that, you say, okay, well, if I'm going to remove the 2x, I'm going to remove it out to the front of what's going on, and then you're going to tell me what's left after you've removed it, right? Well, let's deal with the numbers. 6 divided by 2 is 3. And then the x in the bottom cancels with one of them in the top, and you're left with 3. So x cubed. Go to the next one. That takes care of that term. Minus, here's the catch this time. I changed the sign. It's minus 18 divided by 2. Well, that's just technically 18 divided by 2 with a negative on it, is what that means. Okay, so that's going to be negative 9. The x in the bottom cancels with one of the x's in the top, minus 9x. Okay, and then you look at the last one. 4 divided by 2 is going to be plus 2. The x cancels with the x. Done. Any issues? Okay, let's look at the last one, or E and then F. Okay. Same principle. We're always doing the same thing with these. Okay, we're trying to figure out GCF. Okay, and I would start with the numbers. With like, what can I divide all three of these pieces by in terms of a number? That's your question. Okay, so you're looking at it. You're gonna say, okay, well, I can divide them all by, looks like negative 3. Okay. And that takes care of the number. Let's look at, here's a scenario where I have more than one variable, right? That's not a big deal. It looks like a big deal, but it really isn't, right? You just have 2 variables. You're looking at all 3 of those terms, and you're saying, okay, well, let's just deal with each variable individually one at a time. Okay? So let's just deal with the x's first. What's the biggest number of x's, or sorry, what's the minimum number of x's that I could take from all 3 of those things? It looks like there are 2 in the first one, but 1 in the other 2. So the biggest number of x's that I can take is just going to be 1. I can only take one x out of all 3 of those, which means I can divide each of them by an x, right? So now you've dealt with the number and the x variable, but you still have a y variable in there, right? Well, it looks like I can only take one y variable as well. Okay? I can only take one because you have to take the minimum. Right? So there's your greatest common factor right there. Now the work is the exact same. You tell me if you're going to remove the greatest common factor from the equation, then you better write it out front and then tell me what's left on the inside. All right, we'll start doing the math. You deal with the numbers. -3 divided by -3, that's 1. And then you look at, okay, well, I can cancel one of the x's with one of the x's in the top. So I get an x. And then the y in the bottom cancels with one of the y's in the top. That leaves 2 y's. So y squared. That takes care of that term. Next one. 15 divided by -3. That's going to be -5. The x in the bottom cancels with the x in the top. There's nothing there now. The y in the bottom cancels with one of the y's in the top. We're left with just a y. That takes care of that term. -27 divided by -3. 2 negatives cancel right off the top, so we're not worried about that. So 27 divided by 3. That's +9. And then if you look, x in the bottom cancels with the x in the top. Y in the bottom cancels with the y in the top. Nothing. You're just done. Okay? Anybody have any issues? Okay. This last question is going to be what we're going to call our challenge question, okay? It's a little bit harder. Okay, but the principle is the exact same. Always I'm trying to figure out what my greatest common factor is, or what's the biggest thing I can divide all of those by. It doesn't look like, it looks pretty messy, right? Like, I think naturally if I hadn't done this question before, my eyes probably would have gone towards these things out front, right? When in reality, I see you're just looking for, right? You're looking for okay, you're looking for the thing that's common in all 3 terms. Well, that looks like the thing that's in common. It looks like, if I'm looking at all 3 of those things, it looks like there's a w plus 1 in all 3 of them. Okay, so that just means, okay, that's fine. W plus 1 is my greatest common factor. What does that mean? Well, if it's your greatest common factor, then you're going to remove it. I'm going to move this down here for a sec so you guys can see something. You're going to write it out front, w plus 1, and then you're going to tell me what's left after you remove it. Well, it looks like this isn't much different than what we were doing. It looks like a w plus 1 cancels with the w plus 1. And a w plus 1 cancels with the w plus 1. And the w plus 1 cancels with the w plus 1. You tell me what's left. 4x plus 5y minus 3. Okay. Does anybody have any questions? Hopefully now, so you've watched me do 9 questions now, right? And in addition to what we did yesterday.